This Zoom session is being brought to you by the fractal Snow Point. All right, for today, we'll be discussing the area of a triangle. Three formulas. One easy, one fairly obvious, the other not at all trivial, but very useful. All right, given a triangle, and it has a base B and a height h, given by a perpendicular, an altitude, then that triangle can fit inside a rectangle with dimensions b by h, and the triangle is half the area of the rectangle. So, and for some reason they do use the letter K for area. I guess the letter A is already, both capital and lowercase is already taken up. So K is the area of the triangle that's half of the area of the enclosing rectangle. And the enclosing rectangle is h by b, so its area is hb, is bh. So K, the area of the triangle, is 1/2 base times height, 1/2 bh, fairly obvious. Now, from this, we can immediately derive a formula for the area of a triangle given two sides and the angle between them, a side angle side rule. Okay, base B, distance A, angle gamma. H over A is sine gamma, so H equals A sine gamma. So therefore, the area would be 1/2 HB, which is 1/2 AB sine gamma. Now, okay, if you swap around the letters A, B, C, gamma, alpha, beta, then K is also 1/2 BC sine alpha, 1/2 CA sine beta. In other words, 1/2 length times sine of the angle between them. So these are formulas for areas of side angle side triangles. Elsewhere in the what I call the hourly trigonometry extra credit set, I give you, I include a formula, I derive a formula for the area of an angle side angle triangle. We'll see that later. But then there's the other kind of triangle, the side triangle. And you kind of think of a triangle in those terms usually. Usually you don't really think, you think about the lengths. It makes it nice and rigid, but the angles it's derived from it. Now, so we have given a triangle with sides A, B, and C. What is its area? Well, there's something called Heron's formula, also called Hero's formula, named after a guy who lived in Alexandria. I think the formula is indeed heroic. Here's how it goes. We talk about the semi-perimeter, S. That's A plus B plus C over 2, half the distance around it. Then K, the area, equals the square root of S times S minus A times S minus B times S minus C. Okay, now here we have to go through a fair amount of argumentation. You'll find it in the book. I'll deliver it to you now. By the law of cosine, C squared equals A squared plus B squared minus 2AB cos gamma. And then there's a half angle formula. Cos squared of gamma over 2 is 1 plus cosine gamma, all that divided by 2. All right, so cos squared gamma over 2 is 1 plus cos gamma over 2. That'll be, well, from the law of arc cosines, the cosine gamma is A squared plus B squared minus C squared over 2AB. Put that in there. After a bit of algebra, the square of cosine gamma over 2 will be A squared plus 2AB plus B squared minus C squared over 4AB. And then this, A squared plus 2AB plus B squared is A plus B squared. So there'll be A plus B all squared minus C squared over 4AB. And this is the difference of squares that factors into a difference times a sum. A plus B minus C times A plus B plus C, all of that over 4AB. Now, with a bit of work, a bit more algebra, this is actually more of a summary of the algebra. This we can phrase in terms of the semi-perimeter. A plus B minus C is twice S plus minus C. A plus B plus C is, of course, twice S, all over 4AB. So that simplifies to S minus C times S over AB. Now, if we want to find sine squared gamma over 2, it would correspond with cos squared gamma over 2. That'd be 1 minus cosine gamma, that divided by 2. Be 1 minus, and again, we use our law of our cosines, A squared plus B squared minus C squared over 2AB. After some algebra, that's C squared minus A minus B squared over 4AB. And that is C minus A plus B times C plus A minus B over 4AB from here to here because we have a difference of squares. Then after this, after dealing with the semi-perimeter, this comes out to equal twice S minus A times, and this is twice S minus B over 4AB. After the 2's cancel, you get S minus A times S minus B over AB. So this is the square of cosine of half gamma. This is the square of sine of half gamma. And the reason why we bother with that is that K is a half AB sine gamma. The sine gamma is sine of twice gamma over 2. And by the double angle formula, sine of twice an angle is twice sine angle, sine of half angle, cosine half angle. Throwing in here, the 2 cancels the 2. You get AB, sine of gamma over 2, cosine of gamma over 2. And now, that's why we have cos squared gamma over 2 and sine squared gamma over 2. It'd be sine gamma over 2 is the square root of this thing, S minus A times S minus B over AB. Cosine gamma over 2 is square root of this, S minus C times A times S over AB. Then we merge these together. AB root S times S minus A, S minus B, S minus C. Root AB times root AB is AB. And then AB's cancel. And then we're done. K is square root of S times S minus A times S minus B times S minus C. And there we have it. I grant you this is a little bit of a challenging proof because, I mean, we're talking about areas. So why are we talking about square of cosine gamma over 2 and sine squared gamma over 2? Well, there are, in fact, many proofs. And in fact, anything in math is generally quite a few proofs, potentially infinite. So this is just one of the, well, more elegant, more difficult proofs. So there we have this. So the formula is simple enough. Given A, B, and C, call S their half their sum. Then this square root of S times S minus A times S minus B times S minus C is the area of the triangle. So, for example, here we go. Here we have a sine angle side problem. We're given A and B. A is 3, B is 4. I'm sorry, this looks longer than that, but never mind. And gamma, the angle in between is 40 degrees. What's K, the area? All right. It's 1/2 AB sine gamma. So 1/2 times 3 times 4 times sine 40, which is about 3.856. If 2 sides are 3 and 2, and the angle in between is 110 degrees, and the area is 1/2 times 3 times 2 times sine 110, that's about 2.819. Now, here we have 3 sides, a side problem. A is 5, B is 8, C is 9. The first thing we do is we determine S. 5 plus 8 plus 9 over 2 comes out to 11. So K equals root of S times S minus A times S minus B times S minus C. So it's root of 11 times 11 minus 5 times 11 minus 8 times 11 minus 9. This comes out to root of 396. That's 36 times 11. Root of 36 times 11. Root 36 is 6. 6 root 11 is the area, or approximately 19.8997. Here they have a word problem. And personally, I think a lot of these word problems are just there so they can put a 4-color photograph in the book and thus improve the book's price. But anyhow, here's this triangular building in New York City with sides 163, 87, and 190 feet. And so, what's the area of the building's footprint? We add these up: 173 plus 87 plus 90 divided by 2. After a bit of calculation, the semi-perimeter comes out to 225 feet. So K equals root of S times S minus A times S minus B times S minus C. That's 225 times 225 minus 173 times 225 minus 87 times 225 minus 180. And all of these have units of feet attached. This works out to 565,110,000, 4th power of feet. I'm amazed that Heron was willing to come up with a formula which involves fourth powers of lengths, because that would be a hypervolume, something you see in a tesseract, which nowadays some people are willing to talk about. I knew a friend of mine who spent years trying to visualize a tesseract, but they were too concrete about that. So I'm amazed he was allowed to do that. Anyhow, so, and of course, the square root of a fourth power is a square. So it's a square feet times root 56511,000. And that comes out to approximately 7,517.4 square feet. Okay, now that's how that goes. Let's see about, excuse me. Modules. Yeah, I mentioned that in the, here we go. In the extra credit sets, there's this long list of problems related to what I call hourly trigonometry. Hourly being what I define as an integer multiple of 15 degrees. And after some derivation of various triangles, specifically the 1575 90 triangle. And why are they calling right now? Here it is. Then, excuse me. They can call later. Excuse me. I'm annoying. Right. If it's important, they'll call later. Anyhow, so some trigonometry of 75 and 50, which I'll ask you to derive. And so I ask about what I call hourly triangles and their areas. And here I derive a formula for areas of a triangle given a side and two of the angles. Well, I'll leave it to you there. You start from the law of sines, various examples of this, and area is a half base times a half h1c, a half a sine beta c, which is a half c sine alpha over sine of alpha plus beta sine beta c. So the area of a triangle given a side and two angles adjacent to it is c squared sine alpha sine beta over twice the sine of alpha plus beta. And I'll use that to, I'll ask you to derive areas of a whole bunch of 30 or so triangles, but I'll get to that later. Okay, I think that should do it for now. We have concluded area of a triangle for now. This is good stuff. We've gone through some very good trigonometry over the past 3 days. So next time we'll be doing very simple stuff, damped, harmonic and damped vibration. Some fairly simple formulas. We could go in deeper into it, but I won't. So, okay, this concludes the topic for today, including Heron's heroic formula. So, questions, comments, requests?
I just had a question about like the pace of the class, because we only have like 5 more days of class after
true.
today.
And, well, let's see. Well, is that right? Yeah, I'm gonna have 1, 2. We'll go into 5, chapter 5. I guess we'll just cover. Well, that's a good question. We may do a couple of double sections starting tomorrow, or I think a couple of those I'm considering extra credit. So okay, let's see which sections in 5 do I consider extra credit? Just a second. I'm sorry, I don't have a list here. You raise a good point. Whoa. Excuse me. Sections 2, 5, 6, and 7 are extra credit, but we will cover sections. Oh, this was 4, 5 is sort of extra credit too. So we will cover sections 5.1, 3, 4, and 5. I'll briefly cover 4 or 5 tomorrow and then go on to 5.1. And then we'll have 1, 2, 3, 4, 5. I will cover sections 4, 5, 5.2, 5.6, and 5.7 briefly, because they're extra credit, not strictly assigned. I hope that's okay with you.
Yeah, I was just wondering about that.
It's a very good point. Thank you. Yeah, well, no, we have about enough time for the assigned work, and I'll briefly go over the extra credit, if you don't mind. Okay, more questions? Very well.
When is the next quiz?
Oh, good question. Next quiz. I mean, it should be, I mean, I should have it open up by now. Let me see. Quiz 2, chapters 3 and 4. Let me, is it already open in the Canvas? Let me double check. Hold on. Quiz 2 open. No, it wasn't. Sorry about that. Now it is open. Okay. So you can get to work on it as soon as you wish. Okay. Everything is due. Let's put it this way. Everything is due by the end of next week because that's how it works out. All right.
Oh, so quiz 2 is due at the end of next week.
Thursday. Yep.
Yeah. Okay.
Not a problem.
Wait, so then is there a final in this class?
Yes, and I will open it up for you in due course. There it is. Yes, it too will be due by the end of next week.
By Thursday of next week.
That's correct.
Okay. And the last class is Thursday.
That's
okay.
Not a problem. Or maybe Friday of next week, since the last class will cover some material. Okay, whatever. Let's say it's the Friday of next week. All right.
Okay. Good.
Not a problem. Okay. Well, as Robert Heinlein said, hold on a second. A motion to adjourn is always in order. Okay. Well, motion to adjourn. Is it seconded?
Seconded.
It's seconded. I shall see you tomorrow.
Thank you.
No problems.
Thank you. Bye.
Bye.
Thank you. When will you be inputting the grades? Hello?
Shall I meet ye?
Yes.
Questions?
I was just wondering when we will be inputting.
Louder?
I was just wondering when you will be inputting some of the grades into the grade book.
Sometime after next Friday. When
Got it. Got it. No worries. Take your time.
Yeah, I'll try and be prompt. Okay?
Thank you. Thank you. Have a nice day.
You too.